Hello students, this is Dilip Udhani and today I will teach you one topic of Laplace transform, that is integration of Laplace transform. It is also called division by t, and that is if Laplace of f of t equals to f of s, then Laplace of f of t by t, that is equals to integration from s to infinite f of s ds. Now we will see the proof of this theorem with the help of fundamental definition of Laplace transform. Laplace of ft equals to f of s, and that is equals to integration from 0 to infinite e raised to minus st f of t dt. Now we will integrate this expression with respect to s from s to infinite. So integration of f of s from s to infinite with respect to s, that is equals to integration of 0 to infinite e raised to minus st f of t dt with respect to s from s to infinite. Here s and t are independent variables, so we can interchange the order of integration. Left hand side will be as it is, and that is equals to, first of all we will write down integration from 0 to infinite, then after integration from s to infinite e raised to minus st ft ds, and then after dt. So first of all we will integrate e raised to minus st ft with respect to s. So f of t is constant, so it will be as it is, an integration of minus st with respect to s. Answer is e raised to minus st divided by multiplier of s, that is minus t. Now this integration sign from 0 to infinite will be as it is. Now you have to put down upper limit, so it will become e raised to minus infinite, and e raised to minus infinite multiplied by any finite value, answer is 0. Then after minus sign, and for lower limit s, it will be e raised to minus st ft by minus t. Okay, and dt will be as it is. Now minus minus will cancel out, so it will become integration from 0 to infinite e raised to minus st ft by t dt. Now you can see that integration from 0 to infinite e raised to minus st f of t dt, that is Laplace of ft. Now over here, in place of f of t we have f of t by t, so this whole integration will become Laplace of ft by t. So Laplace of ft by t, that is equals to integration from s to infinite fs ds. So this is the proof of division by t. Now we will see examples based on this theorem. Example number 1, find the Laplace transform of sine 2t by t. So first of all we will find out Laplace transform of f of t, that is sine 2t. So Laplace of sine 2t, according to the formula, Laplace of sine at, that is a over s square plus a square. So value of a is 2, so it will be 2 over s square plus 2 square, and 2 square is 4, and this is f of s. Now according to the concept of division by t, Laplace of sine 2t by t, that is equals to integration from s to infinite fs ds, and fs is Laplace of sine 2t, and that is 2 over s square plus 4. Now we will integrate this function with respect to s using this formula. Integration of 1 upon x square plus a square dx, that is 1 over a tan inverse x by a. So it will be 1 over 2 tan inverse s by 2, and this 2 will be as it is, and limit is from s to infinite. Now 2 and 2 will cancel out. Now put upper limit infinite minus lower limit s. So for upper limit it will become tan inverse infinite, minus for lower limit it will become tan inverse s by 2, and tan inverse infinite is pi by 2 minus tan inverse s by 2. Now pi by 2 minus tan inverse s by 2, that is equals to cot inverse s by 2, and we can write down cot inverse s by 2 as tan inverse 2 by s. So this is Laplace transform of sine 2t by t. You have to remember this formula, that is tan inverse x plus cot inverse x equals to pi by 2. From that we will be having pi by 2 minus tan inverse x equals to cot inverse x. Okay. Now we will see example number 2. Find the Laplace transform of 1 minus cos 2t by t. Here f of t is 1 minus cos 2t. So we will find out Laplace transform of 1 minus cos 2t. So Laplace of 1 minus cos 2t, that is equals to Laplace of 1 minus Laplace of cos 2t. And Laplace of 1 is 1 upon s minus Laplace of cos at. Answer is s over s square plus a square. Here a is 2, so it will become 2 square, that is 4. And this is equals to what? F of s. Now according to the concept of division by t, Laplace of 1 minus cos 2t by t, that is equals to integration from s to infinite f of s ds. And f of s is 1 over s minus s over s square plus 4 ds. Now integration of 1 upon s, answer is log s. And integration of s over s square plus 4. So to integrate this function, what you have to do, you have to multiply numerator by 2 and divide it by 2. So 1 by 2 will be as it is, and in the denominator you will be having s square plus 4 and its derivative will be 2s, that will be in the numerator. Now you can apply the formula of integration, that is integration f dash x over fx, it will become log fx, right? So minus half as it is, and integration of 2s over s square plus 4, it will become logarithm of s square plus 4, and limit is from s to infinite. Now writing this one as 2 by 2 and 1 by 2 will be as it is. Then after applying the property of logarithm, 2 log s will become logarithm of s square minus 1 by 2 into logarithm of s square plus 4, and the limit is from s to infinite. Now taking minus 1 by 2 common, so it will become logarithm of s square plus 4 minus logarithm of s square, and limit is from s to infinite. Now applying the property of logarithm, that is log x minus log y, answer is log x by y. So it will become minus 1 by 2 into bracket logarithm of s square plus 4 divided by s square, and limit is from s to infinite. Now dividing s square plus 4 by s square, so s square by s square, answer is 1 plus 4 by s square, and limit is from s to infinite. Now first of all put upper limit infinite, so 4 over infinite it is 0, and 1 plus 0 answer is 1, so it will become log 1 multiplied by minus 1 by 2. Then after minus sign, multiply minus sign by minus 1 by 2, it will become plus 1 by 2, and for lower limit you have to replace s by s, so it will become same function, that is logarithm of 1 plus 4 by s square. Now log 1 is 0, right? So half into logarithm of 1 plus 4 by s square. You can simplify this function by taking LCM s square, so it will become half logarithm of 1 into s square plus 4 divided by s square. Okay, so this is the Laplace transform of 1 minus cos 2t by t. Now we will see example number 3. We have to find out the Laplace transform of cos at minus cos bt by t. Here f of t is cos at minus cos bt. So we will find out Laplace transform of cos at minus cos bt, that is equals to Laplace of cos at minus Laplace of cos bt. Now Laplace of cos at, answer is s over s square plus a square minus Laplace of cos bt, that is s over s square plus b square, and this is equals to f of s. Now according to division by t, Laplace of cos at minus cos bt divided by t, that is equals to integration from s to infinite f of s ds, and f of s is s over s square plus a square minus s over s square plus b square. Now multiply and divide by 2, you will get 2s over s square plus a square into 1 by 2 minus 2s over s square plus b square into 1 by 2. Now applying the formula of integration of f dash x over fx, that is logarithm of f of x, so it will become 1 by 2 logarithm of s square plus a square minus 1 by 2 logarithm of s square plus b square, and limit is from s to infinite. Now taking 1 by 2 common and applying the property of logarithm, that is log x minus log y, that is equals to logarithm of x by y. So it will become logarithm of s square plus a square divided by s square plus b square, and limit is from s to infinite. Now divide numerator and denominator by s square, so it will become 1 by 2 as it is logarithm of 1 plus a square by s square divided by 1 plus b square by s square, and the limit is from s to infinite. Now put upper limit infinite and lower limit s. For upper limit infinite, this term and this term will become 0, so it will become logarithm of 1, and multiply logarithm of 1 by half, so it will become half logarithm of 1, and after minus sign, half logarithm of replacing s by s, so you will be getting this same function, and log 1 is 0, so this whole term will become 0. Then after you have to simplify this function by taking s square LCM in the numerator and denominator, and after simplification you will be getting minus half logarithm of s square plus a square divided by s square plus b square. Now this half as it is multiplied by minus 1. Then after applying the property of logarithm, so it will become logarithm of s square plus a square over s square plus b square, the whole raised to minus 1, and it will become half logarithm of s square plus b square over s square plus a square. So this is the Laplace transform of cos at minus cos bt by t. Now we will see example number 4. We have to find out the Laplace transform of 1 minus e raised to t by t. Here f of t is 1 minus e raised to t. So we will find out Laplace of 1 minus e raised to t. So Laplace of 1 minus e raised to t, that is equals to Laplace of 1 minus Laplace of e raised to t. So Laplace of 1 is 1 over s minus Laplace of e raised to 1t, answer is 1 over s minus 1. This is equals to f of s. Now applying the concept of division by t, Laplace of 1 minus e raised to t by t, that is equals to integration from s to infinite fs ds. Integration from s to infinite fs is 1 over s minus 1 over s minus 1 ds. And integration of 1 by s, answer is log s, minus integration of 1 over s minus 1, answer is logarithm of s minus 1, and limit is from s to infinite. Now applying the property of logarithm, that is log x minus log y, that is equals to logarithm of x by y, so it will become logarithm of s over s minus 1. Now divide numerator and denominator by s, so it will become logarithm of 1 over 1 minus 1 by s, and limit is from s to infinite. Now for upper limit infinite, 1 over infinite will become 0, so it will become logarithm of 1 minus, for lower limit s we will be having this same term, that is logarithm of 1 over 1 minus 1 over s. Log 1 is 0. Now simplify this one by taking s LCM, so it will become minus logarithm of s over s minus 1. Now applying the property of logarithm, so it will become logarithm of s over s minus 1, the whole raised to minus 1. So finally it will become logarithm of s minus 1 over s. So this is the Laplace transform of 1 minus e raised to t by t. Now we will see example number 5. We have to find out the Laplace transform of e raised to minus bt minus e raised to minus et by t. So here we have f of t, that is equals to e raised to minus bt minus e raised to minus et. So first of all we will find out Laplace transform of this f of t. So Laplace of e raised to minus bt minus e raised to minus et. So that is equals to Laplace of e raised to minus bt minus Laplace of e raised to minus et. And Laplace of e raised to minus bt, that is 1 over s plus b minus Laplace of e raised to minus et. Answer is 1 over s plus c. Now this is f of s. Okay. Now we will apply the concept of division by t, that is Laplace of ft by t. Here ft is e raised to minus bt minus e raised to minus at, and that is equals to integration from s to infinite f of s ds. So integration from s to infinite will be as it is, and f of s is 1 over s plus b minus 1 over s plus c ds. Now we have to integrate 1 over s plus b minus 1 over s plus e with respect to s. An integration of 1 over s plus b, according to the formula integration of f dash x over fx, that is equals to logarithm of f of x. So it will become logarithm of s plus b. Then after this minus sign, now again integration of 1 over s plus a using the formula integration f dash x over fx, that is equals to logarithm of f of x. So it will become logarithm of s plus a, and the limit is from s to infinite. Now here we will apply the property of logarithm, that is logarithm of x minus logarithm of y, that is equals to logarithm of x by y. So it will become logarithm of s plus b over s plus c, and the limit is from s to infinite. Now divide numerator and denominator by s. So it will become s by s plus b by s, and in the denominator it will become s by s plus a by s. So finally it will become logarithm of 1 plus b over s divided by 1 plus a over s, and the limit is from s to infinite. Now first of all we will put upper limit infinite. It means we have to replace s by infinite. So it will become logarithm of 1 plus b over infinite over 1 plus a over infinite, and b over infinite will become 0, a over infinite will become 0. 1 plus 0 answer is 1, 1 plus 0 answer is 1, and 1 over 1 answer is 1. So finally it will become logarithm of 1. Then after minus sign, and then after we have to put lower limit s. So in place of s we have to put s. So we will be having this same function. So minus logarithm of 1 plus b over s divided by 1 plus a over s. Now logarithm of 1, that is 0. Value of log 1 is 0. Now this minus sign as it is. Now we have to simplify this function in the numerator and denominator by taking s LCM. So in the numerator we will be having s plus b over s, and in the denominator we will be having s plus e by s. So s will cancel out, so we will be having simplified form, that will be s plus b over s plus e, and this minus sign, that will be as it is. Now consider this one as minus 1. Then after applying the property of logarithm, that is logarithm of s plus b over s plus a raised to minus 1. Then after logarithm of s plus b over s plus a raised to minus 1 will become logarithm of s plus a over s plus b, because x raised to minus 1, that is equals to 1 upon x. Okay, so this is the final answer, logarithm of s plus a over s plus b. So logarithm of s plus a over s plus b, that is the Laplace transform of e raised to minus bt minus e raised to minus at by t. Okay. Thank you for watching this video.